Hi everybody, this is Gigi from Kauai Community College. In this video, we will be talking about two types of interest, simple and compounded interest. All right, let's get started. All right, here we go, simple and compound interest. Let's first take a look at this example. Interest is a simple interest when it's calculated only on the original amount or the principal that you put in. For example, if you deposited $100 to your saving accounts and that has a simple interest rate of 8%, how much money will you have after 20 years of keeping the money in the account? All right, so according to this definition of simple interest, which is the interest being calculated only on the original amount, which is the $100, right? So the principal is $100. The interest rate is 8%, which is 0.08. And how long? 20 years. All right. How much money do you think you will get after 20 years? Pause and write down a number. All right. Once you come back, let's take a look and see if your guess is close. Okay, so interest each year is 8% of 100, which would be $8. And that amount stays the same each year. So each year you'll have $8. So after year one, you'll have 108. After year two, you have 108 plus $8, which is 116. After year three, you'll have 100 plus $8, $8, and $8, which is 8 times 3. So you'll have 124. And if we do this for 20 years, okay, then the amount of money that you have in your account with an 8% simple interest is $260. Okay, $260. That's not a lot, right? Now, and that is what we call simple interest. The interest is being calculated based only on the original amount. All right. Now, we can look at this and say, oh, this sounds like a constant rate of change. That means you are adding the same amount every year. Constant rate of change should ring a bell. And we would say that's a linear model. All right, so simple interest is when interest calculated on the original principal. And because it is a constant rate of change, we have a linear model, and that is y equals to b plus mx, where where x is the number of years, y is the future value, b is the initial amount or the principal, and m is the interest per year, how much you get per year, that $8. Okay. Now, one thing that we need to pay attention to is the banker's rule that allowed financial institution to use only 360 days a year as opposed to 365 days. So keep that in mind. That's why is that? I think mathematically the number 360 has a lot more multiples than factors than the number 365, right? So it's nicer to use 360 than 365. Okay, so the number of days in a year for the bank is 360. All right, so let's take a look. In 1626, Peter Munich convinced the Indians to sell him Manhattan Island for $24. Now, if the Native Americans have put these $24 into a bank, and that is being paid as 5% simple interest, how much money will they have at the end of the year, this year? So The principal is $24. The rate is 5%, which is 0.05. And from 1626 to 2020 is 394 years. That's many years, right? So how much money do you think they'll have for their 24 bucks? Okay, let's take a look. M, which is the interest rate per year, that's the constant rate of change because it's simple interest. Okay, that would be 24 times 0.05, and that's $1.20. They get $1.20 every year for 394 years. So 1.20 times 394 plus the $24. In 2020, they would have had only $496.80. Okay, that doesn't sound right, right? That's, I don't think is real life. Okay, so in real life, what do? We use, the bank actually use compounded interest. What does that mean? Compounded interest is when the interest is being computed on the original amount as well as the accumulated interest. Okay, that means what? You earn interest on the interest that you have earned previously. Okay, so here's an example. $100, 8%, right? Remember that, 8%. Now, suppose we are going to compound this quarterly, that means 4 times a year. Then that means each quarter, the rate is 2% or 0.02, right? 8% divided by 4. Now, if the year is 20 years, right? After 20 years, how much money would you have, right? Remember that $260. So now it's compounded quarterly. That means you get to earn interest on the interest that you have earned. After 20 years, the interest is being calculated 80 times, right? 4 times a year times 20 years, okay? So how does that look like if we were to do the calculation? Well, after 1 quarter, you will have $100 plus 2% of 100, which is $2, right? So that's the interest. And then after quarter 2, you would have earned the interest on the $2 interest that you've earned before. So the interest now is going to be $2.04. So now you have $104.04. After 3 quarters, you would have earned that same quarterly interest, which is 2%, but not on the $100 originally, but on the $104 after quarter 2. So now we have earned $2.08. Okay, and then after quarter 4, we would have earned $2.12. So if we repeat this process 80 quarters, then the amount in the account would be $487.54. That's a lot more than the $260 you've seen before, right? But what I want you to pay attention to are these. Okay, what do you notice? Changing rates of change, but it's relative to the 2% quarterly interest or the 8% annual interest, right? So when we think of changing rates of change, we say it is an exponential model. All right. So compounded interest is being computed on the principal as well as on the accumulated interest. So you earn interest on your interest, right? That's the definition. And because you earn interest on your interest, we have changing rates of change relative to the percent interest rate, and that is an exponential model. So we would say that is y equals capital B times multiplier to the x power, right? Now, n, it is the number of times that it's being compounded per year. T is how many years, and R is the annual rate. So we have these definitions of variables. Y is the future value. B is the initial value or the principal. M, the multiplier, it's actually, let's take a look at X first. X is the number of periods that you have calculated the interest. So that would be how many times a year times how many years, so N times T. And then the multiplier M is the original 100% plus the quarterly or monthly interest rate, which would be the rate divided by how many times you are compounding this, right? So in the previous example, that would be the rate divided by 4 because it's quarterly. If it's monthly, it would be rate divided by 12, right? Okay. So here, let's take a look at an example. The same example as before, that $24, right, from the Indian, the Native Americans. Let's say if this time though, instead of simple interest, it would be compounded interest, and it will be compounded daily. Okay, compounded daily. In banking terms, daily means 360 days. All right, so B, which is the principal or the initial value, is still 24. N is 360 because it's compounded daily. T is still that 394 years since 16 whatever to 2020. And then X would be how many periods we have gone through when we were calculating the interest. So the number of periods would be how many times it's compounded multiplied by how many years. So 360 times 394. And the multiplier would be 1 plus the rate. Okay, so that's the rate here. That's R divided by N, right? All right. Now, when we plug in that information, we have B, which is 24. This right here is M, and that right there is to the X power. Okay, and we multiply. Okay, now carefully throw that into your calculator. You should get, whoa, that's a lot of money. I don't even know how to read that. Let's see. 1,000, million, billion, 8 billion, 8.6 billion. That's a lot of money. Okay, and what's the difference? Compounded interest is an exponential model. Exponential grow a lot faster, if you remember that from our last lesson, right? All right, let's take a look at some other things that we talk about when we talk about compounded interest. Okay, for example, percent yield. What is that percent yield? Well, that is different than the annual interest rate. Okay, yield percent, basically because you are earning interest on your interest, in the end, if your rate is 5%, you actually have earned more than 5%, right? So that is what we call the yield percent. And in this calculation, 1 plus the rate is 5% divided by 360 compounded daily to the 360 minus 1. And if you throw that into your calculator, the yield percent is, in this case, 5.127% as compared to the annual interest rate of 5%, right? So you're happy if this is a savings account and you see that the interest rate is, the yield percent is higher because that's what you actually are getting, right? But if you were borrowing money and the annual interest rate is 5%, you actually are paying more than 5%. So that's not a happy situation, right? So it depends if we want to talk about savings or loan, right? Okay. Now, another banker's rule that is kind of fun and like very easy to use in real life is the time that it takes for you to double your money when you put into a savings account is to take 72 divided by the annual yield without the percent sign. So in this case, it would be without the percent sign, it would be move over to unit. So that would be 0.05127, right? Okay. So how long does it take for you to double your, actually, what we meant was 5.127, right? Right here without the percent sign. Just that right there without the percent sign, not to change it to decimal. Okay, so it will be 14 years in this case. So we're talking about every 14 years, your money is going to double. So let's take a look at that scenario where you start with the $24 at the beginning, right? After 14 years, you'll get 48. And then after another 14 years, you'll be at 96. And then after another 14 years, you'll be at 192. And if you continue this table, do you think, is it believable that you'll get to that number, the $8.6 billion that we calculated before? Okay, pause the video and try and see. Okay. Now, another thing we want to think about is continuous compounded interest. Okay, what does it mean to compound continuously? Well, you saw that compounded daily is 360, right? Well, what if it's like compounded like by hourly? That would be 12 times 360, and compounded by the minute, multiply that by 60. But if you do this continuously, like you never stop, there's no time in between, the future value is being calculated by future value A is equal to P, the principal, multiplied by E, the number E, raised to the RT, where E is what we call an Euler number and is approximately 2.7. Do, however, use your calculator and use the E button, okay? So that same scenario of $24, 5% annually, 394 years later, with continuous interest, okay? Remember, if it was compounded daily, you had about that 8.6 billion, right? Well, here, if you throw that into your calculator, you're gonna get 8.626. From before it was, I think, 8.614 billion. So this is even more than that, okay? And that is what we call continuous. Now, suppose you are buying a car. Would you want the bank to use simple interest or compounded interest? Think about that and think about why. Talk to your family, talk to friends about simple versus compound interest and debate this question. And that is it for me.